Let me tell you about a man named Carl Sagan, who once said something that stayed in my memory for a long time. He said the nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies were forged in the interiors of collapsing stars. We are made of star stuff. That's a beautiful thing to say. But here's what he didn't tell you. When you're cremated, when your body is placed in that chamber and heated to 760 degrees Celsius, not a single atom of that stardust is destroyed, not one. Your body decomposes, yes. The pattern that was, you disappears, yes, but every atom remains. Each of them. And where do those atoms go? What happens to them during those 2 to 3 hours inside that chamber? That's what I want to explain to you today. Look, this isn't an abstract idea about life after death, souls, or anything like that. This is physics. It's the first law of thermodynamics, which clearly states that matter and energy cannot be created or destroyed, only transformed. And cremation is one of the most dramatic transformations your body will ever go through. It's the moment when the pattern called you ceases to exist, but the atoms that made you up awaken, and they scatter to the wind, literally. Some of them will become part of the air. Others will settle as dust. Still others will remain as ash inside an urn. And each of these atoms carries a story about where it will go next. To understand where your atoms go, we first need to understand what you are made of. And I mean at the true atomic level. The human body contains approximately 7 times 10 to the 27th power atoms. That's equivalent to 7 octillion atoms. 7 followed by 27 zeros, a number that's almost impossible to comprehend. And these atoms are not equally distributed among the elements. No, not at all. Your body follows a very specific recipe. 65% of your mass is oxygen. Not the oxygen gas you breathe, but oxygen atoms bonded to water and all the organic molecules that keep you functioning. 18% is carbon, the backbone of every organic molecule in your body. 10% is hydrogen, found mainly in water, but also in fats, proteins, and DNA. 3% is nitrogen, mostly in proteins and in your DNA. 1.5% is calcium, almost all of it in your bones and teeth. Phosphorus makes up 1%, mainly in your bones, but also in ATP, the cell's energy molecule. And then there are the trace elements, tiny amounts of sulfur, potassium, sodium, chlorine, magnesium, iron, and a few others. That's what you are. That's the complete list. 7 octillion atoms organized in this extremely specific pattern. And somehow this pattern is conscious and able to reflect on itself. Think about that. When your body is placed in a cremation chamber, the temperature rises to between 760 and 982 degrees Celsius. That temperature range is not arbitrary. It needs to be hot enough to break the chemical bonds that hold your body together, but not so hot that it vaporizes everything. Different chemical bonds require different amounts of energy to be broken. A carbon bond, the kind that forms the backbone of organic molecules, needs about 3,000 degrees Celsius to be completely broken. Cremation does not reach that temperature, and it doesn't need to, because what cremation does is break the bonds between the molecules, not the bonds within the atoms themselves. And that's what happens. As soon as the temperature starts to rise, the water begins to evaporate. Remember that 65% of your mass is oxygen, and most of that oxygen is bound in water molecules. Each water molecule is made up of 2 hydrogen atoms and 1 oxygen atom, H2O. At these temperatures, water turns into vapor almost instantly. All the water in your blood, in your cells, in your tissues, it vaporizes and becomes gas. And this gas, this vapor, rises up the chimney and enters the atmosphere. Those hydrogen and oxygen atoms that were part of you, that were in your blood just hours before, are now water vapor in the air. Some will condense into clouds. Others will fall as rain. Some will be absorbed by plants. Others will be inhaled by other people. But they continue to exist. They don't disappear. As the temperature starts rising, something else begins to happen. The organic molecules in your body, fats, proteins, DNA, carbohydrates, start to break down. And what are organic molecules made of? Carbon. Long chains of carbon atoms with hydrogen, oxygen, and nitrogen attached to them. When these molecules break down in the presence of oxygen and heat, they combust. They burn. The carbon atoms combine with oxygen atoms from the air to form carbon dioxide, and just like water vapor, it rises and exits through the chimney. That's where the carbon from your body goes. The carbon that was in your DNA, in your proteins, in the fats that protected your organs, all of that is converted into CO and enters the atmosphere. And do you know what happens? That carbon will be absorbed by plants during photosynthesis. It will become part of a tree, of grass, of a flower. It will be inhaled by animals. It will dissolve in the ocean. It will keep circulating through Earth's carbon cycle for millions of years. The carbon atoms that were once in your body will be in thousands, millions, billions of other living beings over time. They don't stop being useful. They just stop being you. The nitrogen in your body, mainly found in proteins and DNA, also turns into gas. At cremation temperatures, nitrogen bonds break and nitrogen gas, N2, is released. Nitrogen gas makes up 78% of Earth's atmosphere, so these nitrogen atoms simply return to the vast reservoir of nitrogen in the air. Over time, they will be fixed by bacteria in the soil and will become part of plants again, then animals, and maybe even another human being. The nitrogen that was in your DNA, encoding every trait you had, will one day be in someone else's DNA, encoding traits you will never know. But this is where things get even more interesting. Not everything turns into gas. The more resistant material stays solid. Calcium and phosphorus, the minerals in your bones and teeth, remain solid. They don't vaporize, they don't combust. What happens is that all the organic material around them burns, and what remains is the bone mineral, mainly calcium phosphate, along with small amounts of other minerals. That's what people call ashes or remains. The remains from cremation, although they're not exactly ashes in the usual sense, are bone fragments reduced to powder. And this powder, these cremated remains, weigh between 2 and 4 kilograms in an average adult. Think about that for a moment. You start with a body that weighs, let's say, 70 kilograms after cremation. What remains is just 2 to 4 kilograms. Where did the other 66 to 68 kilograms go? Into the air in the form of gas, water vapor, carbon dioxide, and nitrogen gas. The overwhelming majority of your mass leaves the cremation chamber as invisible gas and disperses into the atmosphere. Only the dense mineral structure of your bones remains. You might be wondering why calcium stays solid while carbon turns into gas. The answer has to do with the type of bond involved. Carbon, when it's part of organic molecules, is bonded to other carbon, hydrogen, and oxygen atoms by covalent bonds. These bonds are relatively easy to break with heat, but the calcium in your bones doesn't exist in the form of simple molecules. It's in the form of calcium phosphate crystals, an extremely stable ionic lattice structure. To break those bonds to turn calcium into gas, you would need temperatures around 2,700 degrees Celsius or higher. Cremation doesn't reach that range. That's why the calcium remains solid. And there's one more thing. The calcium in your bones, the phosphorus, those atoms, are ancient. They were formed in the core of stars billions of years ago, long before the Earth even existed. They were part of the cloud of dust that collapsed to give rise to our solar system. They were on the primordial Earth, circulating through rocks, oceans, and living beings for billions of years before becoming part of you. And now, after cremation, they rest in an urn, still solid, still the same atoms as always. And one day, if these remains are scattered, buried, or dissolved, these calcium atoms will return to become part of the Earth. They will be absorbed by plants, by animals, by future human beings. They don't end, they just change form. That's what the first law of thermodynamics teaches us. Matter and energy cannot be created or destroyed. only transformed. And that's exactly what cremation represents. A transformation. The arrangement of atoms that was your body is taken apart. The pattern is destroyed. But the atoms themselves remain, each of them. And that's not a metaphor. It's not poetry. It's physics. Let me tell you now about a physicist named Richard Feynman, who thought deeply about atoms and what they mean. He didn't talk specifically about cremation, but he addressed something related. He talked about how atoms move through living beings, how the atoms in your body now are not the same atoms that were in your body 7 years ago. Your body is constantly incorporating new atoms from food, water, and sweat, and constantly releasing old atoms through metabolism, breathing, and sweat. The pattern stays more or less the same, but the atoms are always being replaced. He said that the atoms that make up everything we see, including our own bodies, were once in stars. And now I tell you that after cremation, those atoms will be in other things. In other stars? No. In other trees, other animals, other people? Yes. And you know what? I think that's beautiful. Not in a sentimental way, but in a physical way. The universe doesn't waste anything. Every atom is preserved. Every atom goes on. The pattern that was you, the arrangement of those atoms that gave rise to your thoughts, memories, and personality, that is gone. But the atoms themselves are, in a certain sense, immortal. They have existed for billions of years and will continue to exist for billions more. Let's be precise with the numbers, because numbers make this concrete. The average adult body contains about 7 times 10 to the 27th power atoms. After cremation, the water vapor release carries away about 65% of that mass. That is about 4.5 times 10 to the 27th power atoms of hydrogen and oxygen enter the atmosphere as vapor. The carbon dioxide released corresponds to about 18% of its original mass, around 1.26 times 10 to the 27th power atoms of carbon and oxygen. Nitrogen gas represents about 3%, around 2.1 times 10 to the 26th power atoms of nitrogen. And the cremated remains, or bone dust, contain about 1.5% calcium, 1% phosphorus, and residual amounts of other elements, totaling around 3 to 4 times 10 to the 26 power atoms. Do the math. All 7 octillion atoms are properly accounted for. None are missing. None were destroyed. They're just in different places in different forms. And here's something practical. Crematoriums have filtration systems to capture some of the particles and gases, but they can't capture everything. They can't capture the water vapor. They can't capture the carbon dioxide or the nitrogen gas. These molecules are too small, too light. They pass through filters and enter the atmosphere. So when someone is cremated, their carbon atoms, their hydrogen, oxygen, and nitrogen atoms are dispersed. They mix with the air. In a few days, some of those atoms will have already traveled hundreds of kilometers on the wind. In weeks, they will be spread throughout the entire region. In months, across the continent. In years, everywhere. And that goes for everyone who has already been cremated. The atoms of every body cremated throughout history are still circulating in the environment. Some of them are in you, right now. You have already inhaled atoms that were once part of people who lived 100 years ago. You have already drunk water containing atoms that were once in the bodies of ancient humans. And one day, atoms that are in your body right now will become part of someone else. That's simply how it works. That's the reality of being made of atoms in a universe where atoms are conserved. Some people find that thought disturbing. The idea that the atoms in your body will become part of other things, that there is no permanence, no final resting place for those atoms. But I find it strangely comforting, because it means you're not separate from the universe. You're part of it. You're made of the same stuff as everything else. And when the pattern that is you dissolves, the matter itself goes on. It doesn't end. It just becomes something else. And this is where people get confused. They say, but if the atoms remain, does that mean I remain? And the answer is no. No way. You are not your atoms. You are the pattern, the arrangement, the specific configuration of these atoms that gives rise to your consciousness and identity. When that pattern is destroyed, you cease to exist. Atoms are just atoms. They hold no memory of having been you. They don't carry your thoughts or your personality. They're just matter following the laws of physics. Atoms continuously circulate through the environment. Think of it this way. A book is not the paper and the ink. It's how the ink is arranged on the paper. The pattern that encodes information and meaning. If you burn a book, the paper and the ink still exist, transformed into ashes and gases. But the book, the pattern, the story, that disappears. Cremation works the same way. The atoms remain, the pattern does not. And that raises a question. What does death mean at the atomic level? Because from the point of view of physics, nothing really dies. Atoms don't die. They just reorganize themselves. A living body is a highly organized system with atoms arranged in very specific patterns that are maintained through metabolism and cell regeneration. Death is when this self-maintenance ceases. The patterns begin to disintegrate, decomposition begins, and cremation is just an accelerated form of this process. Instead of taking weeks, months, or years for bacteria to break down your body, cremation does it in 2 to 3 hours with heat. But the end result is the same. The atoms that were once in a highly organized living system now become part of the less organized environment around them. The carbon becomes CO, the hydrogen and oxygen form water, the nitrogen turns into gas, and the calcium becomes mineral dust. And the second law of thermodynamics, which states that entropy, or disorder, always increases in a closed system, is satisfied. Your body, which was a low entropy and highly organized system, became high entropy, disorganized atoms scattered throughout the environment. And you know what? That's how the universe works. Everything that is organized ends up becoming disorganized. Every pattern eventually dissolves. Stars go out, mountains wear down, living beings age and stop functioning. And all of this, absolutely everything, is nothing more than atoms reorganizing themselves according to the laws of physics. There is no exception for human beings. We are not special in that sense. We are made of atoms, and atoms follow the same rules everywhere. Let me tell you one more thing. The atoms in your body were once part of countless other things before they became part of you. The carbon atoms in your body may have once been part of a dinosaur, or a tree that grew during the Roman Empire, or the ocean, or the atmosphere, or a rock deep underground. These atoms have been circulating through the earth for billions of years, becoming part of living beings after being part of non-living things, and then part of living beings again. And they will keep doing that long after you are gone. There is a calculation that is sometimes done, a kind of thought experiment. If you take the number of atoms in the human body about 7 times, 10 to the 27th power, and compare it to the number of atoms in the atmosphere, about 10 to the 44th power, and suppose that these atoms mix completely over time. So statistically, every breath you take contains some atoms that were once in the body of Julius Caesar, of Cleopatra, or any other historical figure you can name. And the same will be true for you 100 years from now. 1,000 years from now, your atoms will be in other people, and they won't know. They'll inhale you, drink you, eat you, with no idea that these atoms were once part of someone who lived in the 21st century. And that, in my view, is beautiful. Not because it means you continue on in some meaningful way, but because it reveals how deeply everything is interconnected. You are not a separate thing. You are a brief pattern in the universe's atomic flow. And when the pattern dissolves, the atoms go their own way. I have one more thing to tell you. The temperature needed to actually destroy atoms, to break them down into their constituent particles, is not the temperature of cremation. It's not even the temperature on the surface of the sun. To separate the nucleus, to split the atom into protons, neutrons, and electrons, you would need temperatures on the order of millions or billions of degrees, the kind that exist inside stars or in nuclear explosions. Cremation reaches, at most, 982 degrees Celsius. That's nothing compared to what would actually be needed to destroy an atom. So, when I say that no atom is destroyed during cremation, I mean it literally. The atoms are exactly the same after cremation as they were before. Same number of protons, same number of neutrons, same number of electrons. The only thing that changes is how they are bonded to other atoms. The molecules break apart. The atoms remain. And that's the great insight of chemistry and physics. Atoms are conserved. In every chemical reaction, in every physical process, the atoms you start with are the atoms you end with. They just reorganize themselves. And life, death, and cremation, all of that is just chemistry. Just atoms reorganizing themselves according to predictable rules. So, where do your atoms go after cremation? Into the air, mostly. Into the water cycle, into the carbon cycle, into the nitrogen cycle, into plants, animals, soil, and oceans. Some remain together as bone dust for a while, but even those will eventually disperse. They will dissolve in the rain, be scattered by the wind, or be buried and decomposed by geological processes. And over time, over centuries and millennia, these atoms will spread throughout the entire planet. They will become part of everything. And that's not exclusive to cremation. If you're buried, the same thing happens, just more slowly. Bacteria break down your body and the atoms are released into the soil. They are absorbed by the roots of plants. They become part of trees and grasses. They are consumed by animals. They are released into the groundwater. They evaporate and penetrate the atmosphere. The only difference between cremation and burial is the speed and immediacy. Cremation releases your atoms into the air within hours. Burial releases them into the soil over years. But the final result is equivalent. The atoms continue on. And here's the question. You can't stop this. You can't preserve the atoms forever in the way they are now. Even if you tried to seal the body in an airtight container, eventually those atoms would escape. The container would corrode. The seals would fail. Geological processes would break it apart. Atoms always find their way back into the cycle because that's what atoms do. They move, change form, bond, break apart, and bond again. They've been doing this for billions of years and will keep doing it for billions more. So if you take away just one idea from all of this, let it be this. You are not permanent, but your atoms are. The pattern that is you, your thoughts, your memories, your consciousness, that is fragile and temporary. But the atoms that make you up are the closest thing to eternal that exists in this universe. They were here before you. They will be here after you. And now for this brief moment, they are organized in a pattern capable of thinking about itself, of wondering where the atoms go after cremation, of appreciating the strangeness and beauty of being a temporary arrangement of stardust. And when the time comes, when your body is placed in that chamber and heated to 760 degrees Celsius, those atoms will be released. The carbon will become dust and nourish plants. The hydrogen and oxygen will become water vapor and fall as rain. The nitrogen will return to the atmosphere. The calcium will remain as dust. And all of this, all 7 octillion atoms will continue their journey through the universe. Exactly as they have been doing for billions of years. Exactly as they will do for billions more. That's where your atoms are going. That's what happens. And I believe that's a kind of immortality. Not the kind people usually hope for, but the only one the universe offers. The atoms go on. The pattern doesn't. And somehow, knowing that, understanding that makes the pattern even more precious. Precisely because it's so temporary. Because it won't last. Because now, at this very moment, the universe has arranged itself in such a way that it allows you to know yourself, to think about yourself, to understand the laws that govern it. That is beautiful. That's how it works. This is science.